Hi, welcome back to Chemical Engineering Statistics. Now, we will learn about how to make one sample hypothesis testing of the mean. So in general, the procedure for hypothesis testing is as follows. First, we have to formulate two statements. One is the initial claim to be proven, and two is the statement that will be true if the initial claim is false. That's what we know as H0 and H1. Then the statement should be converted to mathematical statement, and that's when we have the H0 and H1. After that, we have to determine the confidence level or the significance level alpha. Based on the data, we need to calculate the value of the test statistics. Then, we find the critical value of variables from the table. We need data such as alpha, degree of freedom, and the properties of the hypothesis testing, whether it's one-sided or two-sided hypothesis testing. Next, we compare the statistical testing position and the critical value in the area of rejection or in the area of non-rejection of H0. Lastly, we draw conclusion by referring to the initial claim to be proven. In one sample hypothesis testing of mean means that we claim testing that compares the population mean with a specific reference value. Some example of the claim is the average score of statistic class final exam participant in the last 3 years is not less than 75. Other example, the average heating value of coal from this mine is not more than 4,500 kilocalories per kilogram. Another example, the average viscosity of brand X lubricating oil in the last 100 production lots is 75 centistocks. Remember that the claims are made against the population parameters, not the sample parameter. In this case, we consider making inferences about the mean of a single population where the variance of the population is known. Suppose that we wish to test the hypothesis where mu0 is a specified constant. Because X has an approximate normal distribution with mean or mu0 and standard deviation sigma divided by square root of n, the statistic test, the Z0, statistic test is Z0, can be calculated as follows. Please note that the subscript 0 indicate the statistical testing parameters for the null hypothesis. In case 2, we consider making inferences about the mean of a single population when we don't know the value of sigma and the samples is small. The step-by-step calculation is similar with the previous case 1, but for case 2, we use the t value and the t table instead of the z table. The approach of hypothesis testing that we have outlined in the previous section has emphasized using a fixed significance level, alpha, and this value will often be 0.05. This fixed significance level or fixed type 1 error rate approach to hypothesis testing is very nice because it leads directly to the definition of type 2 error. However, fixed significance level does have some disadvantage. For example, suppose that you learn that the null hypothesis regarding the mean burning rate of the rocket propellant has been rejected at 0.05 level of significance. This statement may be inadequate because it gives you no idea about whether the sample average burning rate was just barely in the critical region or whether it was very far into this region. This relates to the strength of the evidence against the null hypothesis. Furthermore, stating the result this way imposes the predefined fixed level of significance on other users of the information. This may be unsatisfactory because some decision makers might be uncomfortable with the risk imposed by choosing alpha 0.05. To avoid these potential difficulties, the p-value approach to hypothesis testing has been widely adopted in practice. So the p-value basically is the probability when H null is rejected. We can compare the significance level with the p-value. If the p-value is less than alpha, then we can reject the null hypothesis. Please have a look on the Montgomery book to learn more about the p-value. That's all for now. Thank you and see you in the next video.